Welcome to Econ 317. In this video, we will go over a suggested solution for the review question for midterm 2. And this one deals with own price elasticity of demand. So let's first write down the definition. So notation for own price elasticity is epsilon. It is the derivative of the demand function with respect to P multiplied by the quantity price pair P and Q. So in the first part, we are given the demand function itself, which is quantity equal to 100 minus 5P. And we have to find out the elasticity for P equal to 10. So here I will take the derivative of Q with respect to P. So the first term is a constant, so 0 minus the second term is 5P, the derivative is negative 5. So the derivative turns out to be negative 5. I have been also given that P is 10, so I can find out the quantity, which is given by 100 minus 5 times 10, turns out to be 100 minus 50, I get 50. So now I've got all the terms, I can compute the elasticity. The derivative is minus 5 times P, which is 10, over Q, which is 50. So I have minus 50 in the numerator, 50 in the denominator, turns out to be negative 1. So elasticity is negative 1. We can say demand is unit elastic. Okay, in the next part, in part B, we are not given the demand function. Instead, we are given the inverse demand function, which is price equal to 100 minus 4 times Q. Remember, I need the derivative of Q with respect to P. So I have to convert this inverse demand into demand function. So which means I need Q on the left hand side, P on the right hand side. So let's do this transformation. So I have minus 4Q on the right. So I will add 4Q to both sides of the equation sign, equal sign. And then I have plus P on the left, so I will do minus P to both sides. With this now, we are able to obtain 4Q on the left and then 100 minus P on the right. But I need Q by itself, so I will divide both sides by 4. So now I have Q on the left by itself. 100 over 4 is 25 minus P over 4. So this is our demand function, and now we can take the derivative. So the derivative of Q with respect to P is the first term turns out to be 0 minus the coefficient of P is 1/4 and P is raised to the power 1, so the derivative is minus 1/4. With this now we are given the price. The first one, price is given as, no, we are given now the quantity, and the first part, the quantity is given to be 10. For this quantity, I can compute the price. I can go to the inverse demand directly, which is given as 100 minus 4Q is 100 minus 4 times 10, turns out to be 100 minus 40 equal to 60. Now I have the elasticity dq over dp, the derivative times p over q. So the derivative is negative 1/4 times p 60, q 10, and so now we are able to compute the elasticity here. This is minus 60 in the numerator over 4 times 10, 40 in the denominator, turns out to be negative 1.5. We can say, since the elasticity is less than negative 1, demand is elastic at q equal to 10. In the second part, q is given to be 20. Again, the derivative remains same, negative 1/4. I have to compute the price. So price is 100 minus 4 times q, which is 100 minus 4 times 20. I get 100 minus 80. Price turns out to be 20. Now we can again compute the elasticity. I have got all the terms here. So the slope, the derivative times p over q, negative 1/4 times p is 20 and q is 20. So these two terms cancel out, negative 1/4. So you can see elasticity is greater than negative 1. So I can say demand is inelastic at quantity equal to 20. The third part gives us quantity to be 12.5. Let me compute the price as before. 100 minus 4 times q, which is 12.5. So 4 times 12.5 is 50. So 100 minus 50, price turns out to be 50. Given this, we can again do the same exercise of computing the elasticity, which is the derivative times p over q. So negative 1/4 times 50, that is price, over 12.5, that is the quantity. 4 times 12.5 is 50, so I have 50 in the numerator, 50 in the denominator. Elasticity turns out to be negative 1. We can say demand is unit elastic at q equal to 12.5. So we can see that for linear demand or linear inverse demand, the elasticity depends on the price quantity pair which we are given. In this case, we found quantities at which demand is elastic, inelastic, as well as unit elastic. Now I go to the last part, the third one, where the demand is given as q equal to p to the power negative 0.5. And then we have to compute the elasticity for q equal to 10 and q equal to 20. So I will go to the definition. I need the derivative of q with respect to p. And this time you can see this is p to the power negative 0.5. So I will apply the formula for the derivative. Negative 0.5 times p to the power negative 0.5 minus 1. So this is minus 0.5 p to the power minus 1.5. 0.5 and 1 added together is negative 1.5. And Now I compute the elasticity dq dp times p over q. So negative 0.5 p to the power minus 1.5 times p over q. First, I will like to simplify this expression before applying the values of q and p if needed. So let's see. I have negative 0.5, then p to the power negative 1.5 multiplied by p to the power 1. So powers add up. Denominator is q. So negative 0.5 times p to the power negative. So minus 1.5 plus 1 is negative 0.5 over q. And if you go back to look at the expression for the demand function, that is exactly q equal to p to the power negative 0.5. So I can plug that in. So I have negative 0.5 here, p to the power minus 0.5 over q, which is also p to the power minus 0.5. So these two terms cancel out. What I have is negative 0.5. So the elasticity I have obtained is negative 0.5. And notice here we do not have any P or Q appearing in the expression, which means this elasticity value will apply to every quantity and price pair. So it is the same elasticity when Q is given as 10 or Q is given as 20. So for both Q equal to 10 and Q equal to 20, because there is no Q or P term appearing in the expression for the elasticity. This type of demand is called isoelastic demand. And we also notice that the elasticity is greater than negative 1. So this one is inelastic demand. So I can call this isoelastic and inelastic demand. And this is a good point to stop.